Sample Spaces in Probability by Justin D'Souza. The learning objectives of this lesson are to define sample spaces and describe subset of sample spaces. Apply the fundamental counting principle to define sample spaces. The keywords in this lesson are experiment, outcome, sample space, finite sample space, infinite sample space, and event. So we will come across all these words as we move on. Sample spaces, let's learn about it now. Say, for example, an experiment is something that involves certain chance. Okay, you cannot assure the outcome. It has a possibility of outcome. So the outcome is something that's the result. It has it's the final result which has come in that particular experiment. Now, over here, sample spaces is all the possibilities that can happen in that particular experiment. Say, for example, you're tossing a coin. You have a chance of head or a tail. Both are the sample space, heads and tails. If it's rolling a die, it's 1, 2, 3, 4, 5, 6. And if a sample space contains countable outcomes, say for example, rolling a die or tossing a coin or rolling a spinner, something like that is all finite, which is countable, whereas infinite is something that is not able to be counted. You cannot count it. Say stars in the sky, it's infinite. So these are infinite. And an event is a subset of a sample space, something in like a part of it. Like say for example, I tell all the I'm rolling a die and I want only the even numbers, say 2, 4, 6. That is an event. Now that's just basic. You won't understand much of that. Now let's look over here. You will understand much better. See this. You have a spinner. There's purple, red, and blue. If you're going to spin this, you will land up with one of the answer, right? So this is basically spinning the spinner with red, blue, purple. This is the sample space, and it's finite. You will get one answer. Now, infinite as discrete and continuous. Now you might be thinking, oh, tossing a coin is obviously finite. Yes, if it's just tossing a coin and getting any outcome. But over here you can see tossing a coin until you get two heads. Now, this is a problem because you are not assured of an answer because you might get head, tail, and head, tail, tail, head. Like, when will you get two heads? It will take some time. Yes, obviously, you will get it because maybe you tried 15 times or 10 times. You will have the answer of two heads continuous, or you might have the first two tries itself, head and head. But you cannot assure it's going to happen now. You might have got tail, head, and tail, tail. And it would take, you will get the answer, but you do not know when it is. So therefore, it's called infinite, but it's discrete because you will be getting the answer. Whereas, if something is infinite and infinite, in the sense you have a circle, how many diameters can you draw? You can draw infinite diameters, right? Because from this circle, you can draw infinite diameters, infinite radius. So over here, this is infinite and it is continuous because there is no end to it. It can be continuously overlapping in the sense there's no end. Basically, over here, you know for sure it will take time, but you will definitely get an answer. It's within this. How many diameters can I draw? It's infinite. So this is basically the types of sample spaces. It's finite, infinite. In that infinite, we have infinite discrete and infinite continuous. Over here, that's what exactly is explained. We will look into some problems now. A fair die is tossed once. Now, what is the sample space of the experiment? We are to just write the sample space. Now, it's not about infinite or discrete or anything. It is just the sample space. That is, a die has how many possibilities? 6 possibilities. So it is 1, 2, 3, 4, 5, 6. Very simple. Whereas now, the same die is tossed, but what is the sample space of the event rolling a prime number? Write the outcome to complete the sample space. Now, before we start solving the problem, what exactly is a prime number? We can say prime number is 2, 3, 5, 7, 8, 9, 10, 11, okay, 13, and 17. Now, can you find any similarities? If you know already what is a prime number, then yes, obviously you know. Otherwise, try to pause the video, try to check what these numbers are, and then try to watch the video to understand what exactly is prime numbers. The definition of prime numbers, I'll just define it by myself. It is a number which is only divisible by itself and the number 1, and it cannot be it is not divisible by any other number than itself and the number 1. That means, now look at this number 5. Divisible means when I divide by any number, I should get a whole number. Say if I divide by 5, yes, I'll get a whole number. And if I divide by 1, yes, I'll get a whole number. But all the numbers before this, sorry, less than this, okay, less than 5, which are the numbers 5 by 4, 5 by 3, 5 by 2. Here the answers will be 1.25. Here it'll be 1.33, I guess. Here it's 2.5. So you're not getting a whole number, right? You're getting fractions. Now see any other number, 17. Try dividing this by 16. You will not get a fraction. You will get something with a decimal point. 15, 14, any number less than this until 1. Okay, but 1 obviously will give you the same, 17. And obviously if you divide by 17, you will get the whole number itself, 1. So other than these two numbers, you can't divide by any. It's not divisible by any other less than this until 2. 2 is also, it'll be 6, sorry, 8.5. So that's prime numbers which are not divisible. Now here you have just a die, so all the prime numbers within 1 to 6, 1 to 6, right? It'll be starting from 2. 1 is not a prime number. It starts with 2, 3, 5. So these are the prime numbers. That's it. So that would be your sample space. So it is 2, 3, 5. The example 2 is to represent sample space. Here we have Kimbe, who has a black hat and a red hat. It chooses one hat for each day, Saturday and Sunday. Represent the sample space for this experiment by making an organized list, a table, and a tree diagram. So we'll make all of this. First of all, just a list. Let's make organized list. So what are all the possibilities? He has two hats, red and black. 2 days. That is Sunday, Saturday, Sunday. Okay. Now, what are the how can we write it as a list? So on the first day, imagine he will wear red hat. That's on Saturday, and he wears Sunday also the same hat. It's red, red. Or what he can do is he can wear red and black. So this is one other possibility. Or he can start with black or black and red. So these are the four possibilities which are there. Now this is very simple just looking at it. If it's just such a small number like two possibility, it's so simple, right? But this, is not possible if it's too many. So, I mean, if it's too many, even the table and the tree diagram will be difficult. Now let's try doing a table over here. So how would you do a table is, now I generally get confused because I just write red, black, red, black. No, you need to consider each day. So let me consider Saturday first. Saturday over here. Red and black are the possibilities. Over here, let's do Sunday. Okay. Sunday, again, red and black are the possibilities, right? So first possibility would be red, 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 black, uh, red, red, black, red, and black, black. So these are the these are the table possibilities. You can see this is how you should have on one day two possibilities, again on another two possibilities, and then you can match it up. You can just draw some tables and you can easily get it. So this is one way. I think so the same way is shown over here. Let's just double check it. Red, 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 black. This is just listing it out. The table is over here. Yeah, this is fine. Okay. You should just make sure you write it in a table. Now the last one is the tree diagram. This will have sort of branches, that's why it's called tree diagram. Now let's consider say Saturday, then we will consider Sunday. What is the possibilities on Saturday? You can either wear black or you can wear red. That's it, right? Now what happens on Sunday? If he wears black, he has two choices over here. On Sunday, he can again wear black or red and again black or red. Now imagine there was one more day, say Monday. Then again, it would have been black, red, and all those possibilities. So this is a tree diagram. It's easy to interpret. So on Saturday, you can just have two possibilities because there are only two hats. If it was third hat, then there's another possibility. So Saturday, all the possibilities, just state it down. Sunday, what are the possibilities? You need to add branches to the previous day because there is two more possibilities, right? So now you can see this is one, sorry, that is a very bad circle. This is one possibility, this is one possibility, this one, and lastly this one. So it would be black, 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 red, red, black, and red, red. So this is the thing. And let's just check the tree diagram. So that's how we write it. Over here they have, I've just marked it out. Over here they have written straight lines, it's fine. So whatever the final, you get it over here, all the possibilities, that's the sample space. Now we have a real world problem. Please take time for this, solve it by yourselves, and then continue watching the video. Now we will do it over here. A geometry teacher always breaks her class up into red, yellow, and blue groups. For a class project, represent the sample space for the next two class projects by making an organized list. Copy the tree diagram. Okay, we will do the tree diagram as well. Now into the column in the organized list. First of all, we have already given some of it. You have to just complete this. So we have red and red because let's just note down red, yellow, blue. So next two class projects, right? Here, first possibility is red, red, red. Okay, the one group got red in the first class project, even in the second, the same red. Or it can be red and yellow or red and blue. Now next time, yellow is to start with, yellow red, yellow yellow, and yellow blue. Last one, blue and red, blue and yellow, and lastly blue and blue. These are the possibilities. This is you just organize list. You just write it accordingly. But what if it's a tree diagram? Because I mentioned I'll just do a tree diagram. Let's consider the first project. Now the first, okay? First project. What are the possibilities? Red, yellow, blue, right? For the second project now, this red has how many possibilities? Again, three. Red, yellow, blue. Again over here, R, Y, B. R, Y, and lastly B. So now you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you write it down, it will be R, R, that's the first one, R, Y, R, B, Y, R, Y, 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 B, B, R, B, Y, B, B. So these are all the possibilities which we have now. These are the sample spaces, nine of them. I hope this is clear. This is a very basic concept. Once you understand the gist of it, you can easily solve them. Sample spaces is very basic. Now we have finite and infinite sample space. Let's read the problem here. Classify each sample space as finite or infinite. If it is finite, write the sample space. If it is infinite, classify whether it's discrete or continuous because there are two types of infinite sample spaces, right? Let's read the problem. A marble is drawn from a bag that contains three orange marbles, five green marbles, and four blue marbles. Now here there's a bag of marbles, and if you draw something, you are going to get a marble, right? Just a different color marble, but it doesn't matter. They just want a marble here. So a marble is drawn from the bag that contains three, five, and four different colored marbles. So fine, yes, you will definitely get a marble. So it's finite. No matter what, it's finite. Okay. So the sample space is orange, green, and blue marble. So either one of this you will obtain. So now if you pick the marble in this, one of this, that's it. The sample space is this. It's finite. Whereas over here, a spinner with four equal parts, green, blue, red, and yellow, is spun until it lands on yellow. Now look at this. A spinner is there. It is divided into four equal parts. So, okay, this is not equal, but you get the point, right? It's green, blue, red, yellow. And you're spinning it. Now imagine this is the marker point over here. You're just spinning it up. You need to, yellow must reach on this region over here. You spun it one time, two times, three times. It did not fall on yellow. When will it fall? The possibility of the spinner landing on the yellow, it cannot be modeled. We can't say which turn it'll fall. It can be first, second, third. It can take infinite times, So it is discrete. Yes, definitely it's going to fall because these are the only possibilities. It will definitely fall over here, but we cannot be, sure on when it'll fall. So it's discrete, but it's infinite. So this will be the second part. That's it's so its sample space is infinite because We cannot, assure when it'll fall. But after a certain number of spins, yes, definitely land, so it's discrete. Whereas now look at this problem. A ball is thrown in the air and its heights are recorded in inches. Okay, you're throwing it in the air. So how many heights can be done? There is no unit of height. Even if the unit of height is mentioned, it is basically continuously infinite, right? Because you can imagine the ball is thrown. Okay, ball is thrown, goes up and comes down. There is infinite heights to be recorded. How can you record all of them? It's just not possible. So it's infinite and continuous. Okay, so that's the last case. And now we will go to fundamental counting principle. But before that, a kind request to all of you. Please do subscribe to my channel if you have not yet subscribed. If you're subscribed, thank you so much. And please do hit the like button. It would mean so much to me. And also do share my videos with anyone, those who might find it helpful, any of your classmates or your friends. And I would greatly appreciate it. Now, coming to the fundamental counting principle, now imagine you have a huge certain experiment like where lots of possibilities are involved. It is very hard to do a tree diagram or list out the sample species. But if you want to know the possible outcomes, the total possible outcomes, it's simple. You need to just keep on multiplying the number of possible outcomes at each stage. Just a while ago, we saw about a geometry teacher dividing the groups, two groups, in how many possible ways? So first experiment was in three different groups, and second experiment as well in three different groups. So the total outcomes are 3 into 3, that's 9. So if we know first stage how much it is, second stage how much. Now imagine in the first stage there were 3 and second stage there were 4 possible different colors. Then it will be 3 times 4, that will be 12 and so on. So that's it. We just keep on multiplying all the possibilities at each stage. We look into a problem now. Santiago lists the number of sections available for the courses he will take in his first semester at college. How many different schedules could Santiago create for a semester? So arts history, there is 6 different sections offered. French, there's 5, mathematics 9, arts, sport again, and English 6. So how many different types of particular course he can create? Because he can choose any one of this, one from this stage, one from here, one from here. So now imagine this was like 1, 2, 3, 4, 5, 6. Then for this, if you're doing a tree diagram, for this first course, there are 5 different possibilities over here. This has 5. And each of this section has again 9 different possibilities. And then again 4 and again 6. So it's a crazy lot of options. But you can find the total possible outcomes, the total possibilities by multiplying each sections. So it's 6 multiplied by next one, 5 multiplied by 9 multiplied by 4 multiplied by 6. Just put in the calculator and you get the answer. So it's just by multiplying. It is, okay, they have estimated. I'll tell you about estimation now. But anyways, if you just multiply it accurately, if you just multiply it all, you get this answer. But now you don't want to multiply accurately because say you don't have a calculator, you want to just estimate it. Now here they have given 6250. How do they do that? So what we do is we generally take a nearest whole number which is easy to multiply. Say over here 5 is easy to multiply, right? 5 again. This can be taken as 10, nearest whole number. Like a nearest easy number to multiply. This is again 5 and 5. So now if you multiply 5 times 5 is 25. 25 times 5 is 125. 125 times 5 is 625. Okay, now 5 to the power 4. Basically 5, or this is 5 into 5 into 5 into 5. 25, 125, 625. Sorry, 625. Now you have a 10. Multiply this by 10, it will be 6250. So this is the nearest estimate. So you're just making it to the nearest, 5 or 10 and then multiplying it. But it's not accurate if you just multiply and calculator, it's accurate. So that's it. So just make sure, understand both the ways, but just double check it by calculator. It's more accurate. And see the estimate 6250, yes, is a reasonable answer. Out of 6480, you estimated as 6250. Yes, that's more than near. And now we have another problem. This is a check problem. Please try solving this by yourselves. A sneaker company lets you customize your own sneaker on their website. Using their most popular sneaker as the base, you have the option to customize the color of each part of the sneaker. See, the main color can be of different types. There is 20 different colors. Then the base can be of 12 different colors. Side 29, toe cap 12, sole 2, laces 30. The accurate answer would be just multiplying all of them, but let's do estimate. So 20 multiplied by, what I'll do over here is I'll consider this to be 10, this to be 30, this to be again 10. This I will take it as 2 itself because this is fine, just doubling. This is 30. Now let's use it up. 20 into 10 into 3, 30 into 10 into 30, and then last I'll double it. So what I'll do is I'll leave all these zeros as it is. Let me just look into the numbers. 2 times 1 is 2. 2 times 3 is 6. 6 times 1 is 6. 6 times 3 is 18. 18 times 2 is 36. Okay. All I did is I easily multiplied the whole numbers. 2 times 1 is 2. Times 3 is 6. 6 times 1 is 6. 6 times 3 is 18. 18 times 2 is 36. Now what next? I just count the zeros. 1, 2, 3, 4, 5. That means I'll have 1, 2, 3, 4, 5 zeros. So here you can see it is 36 million. Our estimate is, oh sorry, my bad. It's not 36 million. It is 3.6 million or 3,600,000. Okay, 3,600,000 options. Here you can see the nearest estimate. Which is the nearest estimate? It is 3,600,000. This is the answer which we got. And now if you want to know the exact value, just multiply all these numbers in your calculator and you get it. So you can see when we estimate it's not accurate, but still you know this is close enough, That's the thing. So that's how we solve this. And that's the end of this lesson. It's a simple lesson about sample space. Please be thorough on what exactly is sample space, especially about the finite, infinite, discrete, and continuous. And all the possible outcomes can be easily found out by the fundamental counting principle. I hope you have found this helpful. Please do subscribe to my channel, which would mean so much to me. If you have not yet subscribed, do subscribe. If you have subscribed, thank you so much. Please do like my videos and share it with your friends. And I'll see you in the next video. Until then, happy learning.